and record this class too. Okay, so the first thing you wrote down was the definition of polyhedron. Polyhedron means many surfaces if you break it up into the root words. It's a three-dimensional solid with many polygonal faces. So all the faces have to be polygons. Polygons have straight sides. So a polyhedron, oh, I didn't mean to show that. A polyhedron specifically has like straight edges everywhere. If you look at these examples, they all have straight edges. There's no curved edges, and that's what makes them a polyhedron. Something that's not a polyhedron would be like a cylinder or a cone, a sphere, and we'll get to that in a minute. But anything with straight sides, polygon faces, is a polyhedron. Then furthermore, if you break it up into two categories, we have prism and pyramids. Prisms right here they're like a tissue box. This would be a prism. It has two bases, top and bottom, that are the exact same shape and size. The bases are congruent, and then around the sides are rectangles. So even if the base is a pentagon, then the sides are still rectangles that go all the way around. Or a triangular prism, the two bases are triangles, and then it has rectangles that go around. Hexagonal prism, it shows a hexagon base, and then you have rectangles going all the way around, and so on. Then this bottom portion is pyramids. Pyramids, I don't know about you, but I think of like the Egyptian pyramids. They look like this. You classify them based on the shape of their base. So this is what the Egyptian pyramids look like. It has like more of a square or rectangular base, but a pyramid could also have like a hexagon base or a triangular base or a pentagon base. And then we classify it based on that base. Okay, then over to the next slide. Like I said, if you're not quite done with this, I'll show it at the end so you can get whatever you need filled in. Over on this side are shapes, 3D shapes that aren't polyhedrons. They aren't polyhedron because they have curved edges. So this would be a cylinder, as you can see. Oh, sorry, it's sorry. Okay, be a cylinder, as you can see. It has two circle bases, and those bases are the exact same shape and size. So bases are two parallel and congruent circles. So if you find the area of one of the circles, you also have the area of the other one. Yesterday, we were focusing on triangles, rectangles, and circles, and I said the reason why it seems so basic is because those shapes make up all the other shapes. So for example, with a cylinder, when we go to do surface area, the cylinder has a circle top, a circle bottom, and then what wraps around it is actually just a rectangle. So that would be like a cylinder flattened out. It's just two circles and a rectangle. Just kind of building concepts for later. Then for a cone, looks like this. This would be the base. It has one base. And then the top point right here is called a vertex. And then this information doesn't match the picture, so just cross it out. And then we have a sphere. A sphere would be like a globe or the earth. By definition, it's a set of points that are the same distance from a given point called the center. I have seen this definition show up on testing. It'll say what shape is a set of points that are all the same distance from a given point in 3D space would be a sphere, or in 2D space would be a circle. Okay, then down here we're going to start working with volume. It says surface area and volume. At one point I did both at once and it's too much for one day. So we're just going to focus on volume today. And it starts out with volume of prisms. I'm going to kind of build the concept before I get into the math of it all. The whole concept of volume is like the space inside of the shape. So it would be the space inside of this rectangular prism. Let's say that this was filled with candy, like, you know, those community events or church events where you have to guess how many candies are in the container? You know what I'm talking about? Mm-hmm. Okay. Yeah. There's actually a way to hack that using the concept of volume. So technically, you could count all the candies on the bottom layer of the container and then count how many layers of the candies there are, multiply those two numbers, and you'd find out how many candies are in the container. That makes sense? And it wouldn't matter which shape. You could use a rectangular prism or maybe a cylinder. You'd count the candies on the bottom, count how many layers of the candy, multiply those two numbers, and you'd get roughly the number of candies in that container. So that's essentially what we're doing. If you wanted to even take it further and maybe be a little bit more inconspicuous, you could count the candies that run this way, like the number this way and then the number this way. Multiply those two numbers, you'd get the area of the base in candy, and then multiply that by the layers, and you'd have a rough amount of how many candy was in there. So that's exactly what we're doing with volume. Some people prefer to use a concept to figure it out. There's also an equation, but the equation is essentially what I just described. So to find the volume of any prism, you have to find the area of the base and multiply by the height of the prism. This equation is on the reference sheet. So if you look at prism, volume equals capital B times H. Capital B, if you look at the key over here, stands for area of the base. And something just to make a note of is anything that's a capital letter on here, so there's a capital B, there's a capital P, capital A, anything that's capital, you actually have to solve something to get that value. So area of the base, we have to solve for the area of the base before we put it into that equation. So volume of a rectangular, actually just prism of prism. Volume equals area of the base times height. And so this is height of prism. And then capital B is area of the base. I actually kind of like that there's no numbers here because then those that like to work ahead haven't solved it yet. They're probably like, I was thinking that. Okay. So let's fill in some numbers. So for the first one, it's going to be 4, 4, and 4. So a cube. So the base is a square. So it's just going to be the area equals length times width. So for volume, area of the base would just be length times width times the height. So we got 4 times 4 times the height. And units cubed now because we're working with volume. Okay. Next one, it has a rectangular base, 4, 6, and 3. So the base is a rectangle. Area equals length times width for rectangle. So the volume equals 4 times 6 times the height, which is 3. 24 times 3 is 72 units cubed. Okay, then, sorry, I don't want to go too fast. The next one is a triangular prism. It has a triangle base, and then the height would be right here. So we'll find the area of the triangle. So the base now is a triangle. And the area of a triangle is 1/2 base times height of the triangle. Area equals 1/2 base times height of that triangle.
How does the base not the square that it's sitting?
Well, if you found the area of this and you multiplied by the height, you'd have too much.
Yeah, but then you divide it by 2.
You could divide it by 2. Yeah.
Oh, okay.
Yeah. So essentially, because, yeah. Okay. Just for those. Yeah. Okay, so dimensions here 4, 5, 3. Okay, then equation volume equals the area of the base, which is a triangle, so it'll be 1/2 base times height of the triangle. and then height of the prism. And then I'm going to plug in the numbers. Base of the triangle is 4, height is 5, and then the height of the prism is 3. Then you can multiply these in any order, so whatever you can do in your head. Half of 4 is 2. Bring everything down. Volume A is 30 units cubed. Okay, and then when you're ready, we're going to flip to the next page. Okay, so here we have a cylinder. Remember, we're not doing surface area right now, so you can cross that out. Volume of a cylinder is literally the same equation. So volume of a cylinder is area of the base times the height. The only difference is now the base is a circle. So the base is a circle, which the area of a circle is pi r squared. So just like I kind of showed with the water bottle, you could find the area of the base, multiply by the number of layers, and you'd have the volume of that shape. So here we'll say the radius is 3 and the height is 10. Find the area of base and multiply by the height. So volume equals pi r squared for area of the base times the height. We've been using 3.14 for pi lately, so we'll just stick to that. Radius is 3, and the height is 10. You plug those in, and it comes out to 282.6 units cubed. Does it make sense? Where people really get stuck is where, like on the reference sheet, it just says V equals BH, and people think you can just like multiply two numbers to get it, but you really have to solve for that area of the base, whatever that base is. And then my rings just like fell off this one. Okay. Next, pyramids and cones. Pyramids and cones have a similar equation. With a pyramid, like if you were to find the area of the base and multiply by the height, you have too much area and space now. So this amount of area is actually 1/3 the volume of a rectangular prism or a cylinder for a cone. So to find the volume of a pyramid, you find the area of the base, multiply by the height, just like in the last equation, but then you divide by 3 or multiply by 1/3, however you want to think about it. Volume of a pyramid. Okay, on the reference sheet, it does have it right here. Volume equals 1/3, capital B H. Volume equals 1/3, capital B H. Again, area of base. And then height of the pyramid. Okay, the dimensions here we'll go with 5, 5, and then a height of 6. Volume equals 1/3. The base is a square, so just 5 times 5, and then the height is 6. There's different ways you could do this in a calculator. I'm going to use the fraction button. It comes out to 50. So it's actually the same equation we were just using, except we divide by 3 because it doesn't take up all the space of a prism. Okay, next one. Good. Cones. Volume of a cone is, to find the volume of a cone, you find the area of the base, multiply by the height, and then divide by 3. Volume of a cone. Volume equals 1/3 area of the base times the height. The difference here, though, is that the base is a circle. Base area equals pi r squared. This is a circle. The numbers we'll use are, let's use 3 and 6. Volume equals 1/3. Base is a circle times the height. When we solve this, we have to make sure to square the 3 first. And then multiply these 3 numbers in a calculator, and it comes out to 56.52 units cubed. Do you remember doing this before at all? You do? Okay. Some of you know. Okay. Then volume of a sphere, the last one. The equation for this, again, on the reference sheet, which is nice, 4/3 pi r cubed. The biggest difference here is r is cubed, which kind of messes people up sometimes. 4/3 pi r cubed. The radius we're going to use is 4. So volume equals 4/3, 3.14, 4 cubed. Make sure to do the exponent first. Comes out to 64. That's us all. Okay. So now you can start your homework. If you have questions, let me know. Just grab a laptop